on this computer. Okay. Can you open our regular class? No? This is if you have seen some of this already. Okay. I recommend that you look at these videos. No, they are from a very important source, a very popular source in uh, computing. No, this is Introduction to Computing. Our suggested book is this, but as of the moment, it may not be followed anymore because I'm using different sources from the net. What we will follow strictly in our syllabus is the outline presented in Dagler. Do you follow? So ito ang isusundin natin. The outline presented in Dagler. Okay, any questions? So ito. Now, if you have questions during this first meeting, you can post them. So this is CS, what's this? CS 301, I think, no? Yeah, that's CS 301. You can post your questions here. Every now and then, I'll be posting some uh, forum, no? Fora for you to ask questions regarding topics that we discuss. Okay, so this is Introduction to Computing. Can you look at your, our syllabus also? It's here, no? You open this. So this is the topic coverage which we will cover. No? I'll be upgrading this. No, there are topics that I will mix and match. No, so this is just a guide. No, but the main topic sequence that we'll follow is the one in Dagler. And then I may still add more topics. No, marami pa akong idadagdag na topics because this site is always undergoing upgrades. No? So there are topics that I'd like to add, particularly at the last, like topics on computer networking and a very recent topic in introduction to databases. No? Why? What is introduction to computing? This is your crash course to the 4-year course that you will spend in Ateneo de Davao. Do you follow? So this is like uh, uh, a short preview, no, of all the subjects that you will take while you are taking IT. Okay, while you are taking IT or CS or DS we'll be meeting twice a week. No, do you follow? No. Okay, we'll be meeting twice a week, and during our lab time, we'll be meeting occasionally. No, especially when there are scheduled activities, because there will be activities that I would like to schedule. Okay, they follow, but I will inform you beforehand. Otherwise, you will be using your lab time to solve problems that we'll give in class. Okay, any questions? So in short, no, this is like a preview, no, of your 4-year course in Ateneo as an IT, CS, or IDS student or data science student. So we will have topics such as the history of computing, what is computing all about. We'll look at topics like Boolean algebra, arithmetic, because this is the basic, how computers work, how computers do arithmetic computations. So we'll take up topics in Boolean algebra. And then we will take topics on computer hardware. Okay, topics on computer hardware. And then we will go through Boolean design. Bakit may kulang? I think there are things that I have missed. So anyway, I'll bring them up. Meron, basic logic circuits. This is important. How computers work. Do you follow? What are the different components of a CPU? You must have underwent them during your senior high. But this time, we'll be looking at them in more detail. Detail that we need in order to create or understand future programs. So any questions so far? No? So we will have a lot of Boolean algebra. And then we look at components of a computer system, the internal components of a computer hardware, the structure of a central processing unit. We'll have classes of CPU registers. Now, these are not just topics. There are problems that you will solve. Problems that will enhance your understanding of the content. So we also have videos which I referenced from the internet. what are registers, what is random access memory, how computers calculate, no? What is the arithmetic logic unit? We will take this up, no? The actual structure in terms of Boolean logic, no? Boolean logic, you know what it is? If you don't know, it's just binary system, no? Zeros and one. Advanced CPU designs, no? And then we will introduce simple topics in operating systems, memory, file systems, no? And then we'll have a little programming, okay? Do you follow? No? We will have a little HTML, okay? Enough for us to create a simple web page. We will be creating web pages, by the way, no? So you will be creating them and we will launch them in the net. Now, there is a, in W3 schools, no? In W3 schools, you can start creating an account in W3 schools, no? You have a free, uh, you have a free space which you can use, no? Pwede ka mag-login dito, no? I'll show you the I have mine already, no? So you can create a web page and uh, publish it, no? In W3 schools, no? Actually, maraming sites ang nag-offer, but in our case, no, we can launch our your personal websites, no? In w3schoolspaces.com, no? Any questions, no? Kasi gagawa tayo ng HTML, no? We'll discuss HTML and we'll create web pages. We will have programming, no? The programming language which we will use is called JavaScript. Any questions? No? Ang ating ano, hindi na tayo mag-GitHub. You can just send your assignments, your web pages through Daygler, and at the same time launch it in W3 Spaces. Do you follow? No? We'll be using a special editor called Visual Studio Code. Okay, if you haven't met this is just a text editor, no? Just like Notepad. You can use Notepad if you like. Okay, any questions? Or you can use some others. There are many others, no? Na pwede, no? If you have developed written web pages before, no? What's I forgot, but there are so many, no? We'll be using Visual Studio Code in discussions, no? And then if we have time, no, as I've told you, I'm going to discuss introduction to SQL. It's not yet in our list of topics, but all of you will take databases, so we might as well. We'll only take the simplest the simplest topics. Okay. So you will have to download a MySQL workbench aside from a Visual Studio Code, and then you will have to install your own MySQL. Anybody can do this, no? I presume nowadays, no, every student can do this. Students, especially those who have undergone senior high. Okay, so magdaragdag tayo ng SQL, and then for programming we'll discuss JavaScript, no? We'll be writing simple programs such as computations, no, in grades. Sir, required pa rin po ako na tapos ko na po kasi ang SQL. Everybody is required, no? As an introduction, hanggang select lang tayo dito. Okay? Jenica, hanggang select lang tayo, no? Simple select, no? So, everybody's required, no? You can have this as a review. Those who have undergone the topics already, you have to bear with us, no? You can take this as a review because we'll have to repeat them from scratch, no? Like Miss Sevilla here, who's in 4th year, so tapos na siya ng whole. By the way, all of these are previews, no, to your future courses or subjects during your stay in Ateneo. For example, your Boolean logic and your Boolean algebra, you will be using this in your digital design class, no? So digital design class maybe during your 3rd year, and then your components of a computer hardware, you will be using this as your base knowledge for computer architecture and computer organization. I think some of you will not take computer architecture, but all of you will take comp org. So components of a hardware, what is RAM, ROM, no? You will be using these instructions and programs, no? You will be using this as background for a later course which in computer org. Any questions so far? And then your programming, you will have a lot of programming. Okay, we will take the basic concepts such as assignment statements, variable declaration, uh, formulas, no, of course, no, and then we will have branching using if, then, and else, and repetition using loops. No, yeah. Have you gone through this during senior high? I presume some of you haven't. It depends on your track, no. Those who are in the science and technology track may have done a little programming, no, or a lot of programming, maybe. But we will repeat them anyway, no. So we'll be using JavaScript. Why are we using JavaScript? Because during online classes, no, JavaScript is the easiest language to learn. You don't need anything, only a browser. Do you follow? No. So you don't need a compiler like Visual Studio. Visual Studio Code is just a text editor. Okay? Any questions? Okay. So gagamit tayo ng programming languages. You will have. I hope we can have ano no. We can have styling, no? Cascading style sheets. Have you done through web development, HTML? Anybody in senior high? Have you all gone through HTML in senior high? No? Kasi may iba last year, wala. Pero don't worry about that, no? Kung wala, it's okay. So, I hope we can have styling, no? The very basic, kasi kailangan nating mag-create ng menu. I think we'll have to do styling like bootstrap, cascading style sheet so you can decorate or improve your personal website. No? So, gagawa tayo ng personal website, no? Which you launch in W3 Spaces. But you can use any platform, no? To launch your personal website. Anyway, you should have a personal website because it is where your assignments in HTML and JavaScript that you will post, no? You will post that your assignments there, no? Don't go to check. All assignments I will check in the net. At the same time, I will require you to submit a text version. Okay? So sa programming ng JavaScript, we will discuss the methods, no? Alert, prompt, and confirm, the different JavaScript data types, variables, and how to declare assignment statements. And then we will write JavaScript functions. No? They're very close to C++ anyway. Halos pareha lang. So we will demonstrate adding of numbers. No? Okay. And then we will have grade computation for if then else. No? And then we can split our JavaScript from our HTML by pointing to a different file. And then we have loop counters and accumulators. If you don't understand what I'm talking, don't worry. Okay, we'll go through them. JavaScript while statements. We will have I will show you a special program in JavaScript which is very familiar. No? It's called an online shopping cart. Do you follow? Online shopping cart. No? Gagawa tayo niyan. And I'm going to show you that. And then you will launch it in your personal web page. We'll discuss aggregate data types such as arrays and arrays, no? And then objects, no? So kaya nga magkaroon dito tayo ng simple shopping cart. We'll create a payroll program, no? And then yeah, we'll discuss computer networks and introduction to databases. Ito yung idadagdag ko later. I'm sure we'll have time because unlike last semester, when the pandemic just started, we had a lot of disturbances. No? Na-short yung aming klase by almost a month because we have been postponed for 2 weeks. So, ngayon tayo, wala tayong postponement so we can have the whole 36 weeks, I think, no? For discussion so we can introduce more topics. Okay. What did I forget? So, idadagdag ko. Okay. Okay. So any questions so far? Any questions? So can we start formally na? When you're starting computing, the most important question is how did this all start? It's like asking how was the automobile invented? Who invented the automobile? Nobody, no? The automobile was an evolution, no? Starting from the invention of the wheel, the push carts and the others, no? So like the invention of the automobile, computing is an evolution of technology. So if you will ask, who invented the first computer? For sure you can name someone, right? But it is not the same as computer as we have today. No, uh, it started to be a very simple design, which later was uh, continuously improved to become what is the modern computer that we are using today nowadays. Okay, so may I ask you, do you know who invented the computer? Who invented the computer? It's not Bill Gates, right? Nor Steve Jobs, because they are of course they have very important contributions to computing, but they did not start. They are the later, no, uh, developments. They came later in the development of computing technology. Okay, so why do we need to study history? It is because by understanding the evolution of things that we are able to use them more effectively, right? And understand the nature of the modern design. Like if you ask, describe a computer according to the modern concepts, it's very difficult to do that, no? Because it's computer concept, the structure of a computer is already very complex. But if you will study how did it all start, you will get to understand how it came to be. If allow piecemeal by piecemeal, we will understand the evolution of things, and it will be easier to understand computer organization if we study its evolution. They follow how it came to be rather than what it is right now. Do you get my point? No? Ang hirap kasi i-describe yan. Kung ganito ang computer ngayon eh, that's very complex, no? But if you will describe it how it came to be, it will be easier for us to program computers if we know its evolution. Okay? Do you follow? So, computing history started during the modern period. What do you mean by the modern period? Kasi world history came into different periods, di ba? During the Roman period, then there were the Dark Ages or the medieval ages, and then there was the modern period. Okay, this is the modern period that we are talking about here. This is not the modern period of computing, but this is the modern period of the world history. Do you follow? Okay, when did the modern period start? About 1500s to 1600s, no? So ang tagal pala, no? Since Christ died, no? It came 1,500 years later, after the death of Christ, that the modern period can more or less officially be recognized as having started. Okay? Do you follow? Bakit ganon? Because modernity and technology, when did the modernity and technology start? They started by technology became modern during the Roman times, di ba? Because who invented the development was very fast during the Roman period. Why? Because it was during the time that so many inventions were done, like the invention of the wheel, the invention of engineering, no aqueducts, the invention of designs of cities, no urbanization, no the political structures, no governments were starting to be established during the Roman period. They follow different inventions like war equipments, no farming equipments, no so many inventions were invented. This was the the fastest, no, one of the most the, quickly developing times, no during the of technology was during the Roman period. Do you follow? Do you follow? But the Roman Empire was defeated. No? The Roman Empire ceased to exist during the 5th century, 473 in particular. Pagdating ng 473, year 470s, the Roman period was defeated by different tribes in Europe, no? Such that after the Roman period, the Western Roman period, no, the Roman period that the Roman Empire that was based in Rome, because there were two Roman empires, no, that was based in Rome started to exist as rather stopped to exist during the 5th century. And Europe was divided into different countries because the whole of Europe was one nation during the Roman period. So after that, no, when the Roman Empire was defeated, Europe entered into a dark ages. It was subdivided into several countries, no, nagiging England, no, and then there was France, no, they were divided. The Goths, they were called France, no. So during the year, the 5th century until the 15th century was considered to be the dark or the medieval ages. Why is it called the dark ages? It's not because there was no electricity. It was because development was very slow. There's not much development during those period. Wala masyadong invention in terms of technology. No? Walang invention. That's why they're called the, the dark ages. Now, the modern period started during 1600s, the 17th century. Ito yon, the early modern period. Europe was divided into different countries, no? And then there was France, no? Which there was Germany, and there was England, no? These competing nations, no, started to come up with different developments in technology, no? Particularly in France, no, during 1642, this is the middle early modern period. Ibig sabihin, Europe started to go out of the dark ages. Do you follow? 1600s, that's the time when 1500s, no? That's about a century when the Philippines was discovered. Okay? Okay? Do you follow? So 1642, there was an invention of a mechanical calculator by Blaise Pascal. Okay? Nowadays, the name Pascal is popular because of the programming language Pascal, which is still in use today. No? 1642, mechanical calculators that could do addition and subtraction was invented in France. No? That was the beginning. It's not yet a computer. It's only a mechanical calculator that could do addition and subtraction. It's called a Pascaline. Let's look up for that. No? Pascaline image. Okay. So ganito yung Pascaline, no? Tingnan mo yan, okay? Can you all see that? Okay. So there are no keyboards, no? So in order to compute, no, you have to make use of wheels, no? I think each wheel can represent 10 digits, no? So this is digit C, the digit of ones, the digit of tens, the digits of ano. Now to be able to do addition, you have to turn it clockwise, no? To do subtraction, you have to turn the wheels counterclockwise. No? So parang ganon, that's invention. But before the Pascaline, there was also already the abacus, no? Ang abacus nandiyan na. Who invented the abacus? We don't know, no? The abacus is the same thing. Halos same concept sila, no? But instead of using wheels, the abacus uses beads, no? In different columns. The first column is the column of ones, the columns of tens. Parang ganon din siya. Do you follow? But the Pascaline uses wheels. Okay? Do you follow?
Yes, sir.
So 1673. That's the birthday of... No. Wala na. Christopher Columbus already came here. No? Tapos na, wala na siya. 1500s pa. Wilhelm von Leibniz, no? Physicist from Germany, designed a calculating machine called step reckoner. which was an expansion of Pascal's idea. It's like Pascalin's machine, no, yung step reckoner. But on top of that, it can do multiplication, no, by repeated addition or shifting. Leibniz was a strong advocate of the binary system. Kasi during those times, people still calculate in decimal. Ang gusto ni Leibniz, convert decimal into binary because it's much easier to implement in a machine. Let's look for a step reckoner. Step reckoner. O, ayan. Okay. So, it's like a modern adding machine, di ba? Have you seen an adding machine in an old Chinese restaurant where you have to punch and then, no, clutch? There's a clutch here, no? The mechanical adding machines are actually an improvement of the step reckoner by Wilhelm van Leibniz from Germany. Ito. So, nagko-compute na siya. No, instead of using turning wheels one by one, you will have a crank. We don't know how this works. We don't have to study how this works, but we only have to mention this in their occurrence in history. No? Hindi na kailangan. Okay. 1801, no? 1801. Pagkatapos nung ma-invento yung ano, so meron na silang calculator that can now do multiplication. Wala pang division. Joseph Marie Jacquard, France, 1801. Invented a punch wooden cards. This is a recording system. Do you follow? Yung punch, early compute, they used to record numbers. No? It's like a modern memory. Actually, it's called a Jacquard loom. No? A Jacquard loom is used for weaving fabric designs. Do you follow? But later, Joseph Marie Jacquard, later, no, discovered that this can be used to record data. No? The Jacquard's loom. Let's look at for Jacquard's loom. Ito. Kasi ganito, let's look at for this. No? Ito. This is Jacquard's loom improved, no? or added with a functionality to record punches. No? Kasi yung mga looms, pwedeng holes on the cards can be used to insert looms. No? Okay? And then the looms can now be used to record the data that is recorded on the card by the whole sequence that is there. So a whole sequence records particular data, primarily binary. So ganito. This is not a computer, no? Jacquard's loom is not a computer, but this is a recording device that can be used to store data. Okay? So that was invented in 1801. Okay? Uses punch wooden cards to automatically weave fabric designs. Basically, used for design of fabric, but later used for recording, no? Recording data in punch cards instead of woods. 1820, so nagkaroon na tayo. 1820 was the first mechanical calculator by Thomas de Colmar from France. No? 1851 to 1915, it's called the arithmeter. It's like your old adding machine in a Chinese restaurant. Kasi mga Chinese lang. Hanggang ngayon, meron pa kaya ito? Okay. Arithmeter. Ito, no? This is the first mechanical computer. Mechanical calculator. I'm sorry, bakit ang daming advertisement? Ganito, no? The first mechanical calculator. Okay? Okay? So that was the early modern period. Now, from 1600 to 1700s, no? The modern period started in 1800s. There was a very important invention during 1822. Believe it or not, it was the time when the computer was first invented. No? Who invented the first computer? Charles Babbage from Great Britain, no? London, England. No? 1822. This is not yet the no, no. The first computer was called the analytical engine. Okay, we will study this. No, we'll look at the structure and we'll program the analytical engine. Remember, no, 1820 meron ng calculator. Pag 1822, Charles Babbage invented the differential engine, which was designed to tabulate polynomial functions. No, because during that time there was already calculus and there were already polynomial functions. It used decimal number system and was powered by a cranking handle like an ano. It was never put to use, no. It was a crazy invention by Charles Babbage. Remember, tabulate polynomial functions. No? There are so many polynomial functions. You can only do that on a modern computer. But during those days, no, Charles Babbage already had an idea, no, to tabulate. His more important invention came in 1837. It's called the analytical engine, which was proposed to be the first mechanical general purpose computer. No? He was recognized as the father of contemporary computers, or the first inventor, the inventor of the very first computing machine. No? So who invented the computer? Charles Babbage. Okay, we'll look at the invention. No, we'll just not mention it. We will look at the invention later. No? Any questions? Any questions so far?
None
None
so
po,
far,
sir.
sir.
Okay, thank you. You chat me, no, if I'm talking too fast. Now, aside from the machine itself, another important invention came in the 1800s, no, by the invention of Ada King, Countess of Lovelace. Lovelace is in it. Augusta Ada King is a Countess of Lovelace in Great Britain. No, he is an avid follower of Charles Babbage. In fact, it was Augusta Ada King, who first demonstrated that Charles Babbage's invention can be programmed. No? Ang invention niya na analytical engine can be put to actual use or can be programmed. In fact, she wrote rather several programs to show that the analytical engine is a working engine. Do you follow? She was the first to recognize that the machine had practical applications, no, beyond pure calculation, like computing. We will show, no, sample programs, no, in the analytical engine, even to compute grades, no, pwede. She was the first to recognize that the machine invented by Babbage had applications and published the first algorithms, no, intended to be carried out by such a machine. In fact, she was known to be the very first computer programmer. Kasi siya ang sumulat ng first program to be run by the analytical engine invented by Charles Babbage. She is widely regarded as the first to recognize the full potential of computers and as one, in fact, the very first computer programmer. Okay? If you're asked nowadays, who invented the computer? It's Charles Babbage. Who is the first programmer? It's Augusta Ada King, no? Yes. There's a question from Tony Labrador. Is the analytical engine the first invented computer or the differential engine? It's the analytical engine, no? The analytical engine, okay, not the differential engine. The differential engine is not a computer. Okay? 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 Any questions so far? No? Analytical engine is the first computer. Okay? Then, 1884, in the US, no, Herman Hollerith invented a recording machine, no, to record punch cards, because during those times, no, the US came out of the Civil War and then 1700s, no, and they were counting their people, their citizens. They were counting their citizens, so they were having a census of citizens so that they'll be able to account who are the legal US citizens who are already there. Okay, so an American inventor invented a recording machine. Okay, It is not a very noble invention because it was also an improvement of Jacquard's loom. Gumagamit na siya ng punch cards, but the punch cards were invented during 18 when was that? 1801. So he borrowed the idea from Jacquard's loom and invented the punch card recording machine, tabulating and recording machine, patented in 1884. No? Kasi computers are not just used for calculations, but they're also used for recording. So kailangan merong memory, diba? Hindi pwedeng walang memory. If there's a computer, there must be a memory. Okay? So aside from the CPU, there must be a memory. So the first inventions related to memory is the invention of the punch card in 1884 by Hermann Hollerith. No? Hermann Hollerith is the father of a very important company. It's called IBM. Okay? IBM siya yung nag-establish ng IBM. Okay? Any questions so far?
None po, sir.
Okay, so you can look at this. Now let's look at the analytical engine. Okay, we will just finish this now, the analytical engine, and then next meeting we will solve problems. Maybe we have time. If we have time, we will. I'm sorry. Okay. Let's look. How does the analytical engine look like? Merong mga bagong pictures, no? Wala the analytical engine was never put into actual into an actual hardware. Do you follow? The images that you see now are actually inventions of universities. No, there are universities that were so fascinated of Babbage design. They want to prove that it was Babbage who already invented the first computer. They implemented. No, they implement. I'm not sure who implemented this, but this is from the US. No, even in the 1900s, 1990s. No, merong invention putting the implementation of Charles Babbage's analytical engine. Charles Babbage, no? I'm sorry, no? Kasi French in India, English pala, no? Sorry, no? Charles Babbage had this. So ito. No? These are modern implementation, no? Inventions. These are not 1600 machines, no? Hindi. These are modern inventions of Charles Babbage engine. Okay? Do you follow? Because they wanted to show or demonstrate that what Charles Babbage invented was an actual computer. Okay? You follow? These are the main components. No? First, there's a store. Okay? So, ang kanyang input consists of formulae. No? So, the commands are in formulas. No? And data provided by punch cards. The data is provided is stored in a punch card using Jacquard's looms. No? Do you follow? The machine was also able to punch numbers onto cards and read it later by using the holes, no, the whole sequence. It employed ordinary base 10. Problema lang ito, decimal pala yung analytical engine. It was later revised, no, by some other inventors, no. It employed ordinary base 10 decimal fixed point arithmetic. So what do we mean by fixed point arithmetic? Kasi yung calculator natin ngayon, floating point. Ibig sabihin, limited yung number of decimal places that it can compute, no? So limited yung number of decimal places. Hindi pwedeng marami, no? But there are only 10 decimal. So maybe if it's a fixed point, maybe there are 4 decimal places and 6 integer places. No? It has a component called the store, no? Originally, it's called the store. Nowadays, we call them the memory. No? So meron na siyang memory, but Babbage calls them the store, capable of holding 1,000 numbers of 40 decimal digits. Do you follow? So each number pala is not, it's not 10 digits but 40 decimal digits. We don't know how many is the float, is the decimal point here. No? The second component is called the mill, which would be able to perform all four arithmetic operations, plus, comparisons, no, and even square roots. Now the mill nowadays is called the arithmetic unit, no, and together with the mill and the memory, you will have the central processing unit. Do you follow? The mill and the memory, you will have the central processing unit in a modern computer. Okay? The mill would rely on its internal procedures to carry out some of the more complex instructions. So ganito pala yon, no? Ang ating program is in the mill. Do you follow? The commands are stored in the mill. The data used by the commands are in memory. Do you follow? And they are fetched one by one by the analytical engine, no? Do you follow? So, iba yung ano, the commands are in the mill and the data is in the store. Do you follow? So that's the distinct characteristic of Babbage analytical engine. No, magkaiba yung command nasa mill, yung data nasa store. Okay? Unlike nowadays, no, both the command and the data are in the store, no? Sa kanya iba. Okay? He designed it that way because of the limitations of the technology during those days. Okay, no. So programming na tayo, no? So I have here no, a material from the Stanford, no? How do we program the mill or the analytical engine? So ito 'yon, no? So merong levers, no? They're just this is the mill, no? The mill is just a set of levers, no? They are called ingress. Ingress is just I'm sorry, x and y axis, no? Basically, the mill can store two different variables, x and y. The first variable is called ingress. The second variable is called egress. What's the distinction? Ingress is used for input. Egress is used for output. Do you follow? So you have two ingress columns, no? So for example, you have ingress 1 and ingress 2. If you have a command to add two numbers, you place the first number on ingress 1 and the second number on ingress 2. And you place a command on the mill. No? Itong numbers nandito sa store. And the command on the mill is the plus. Do you follow? So you have 3 plus 2. So ingress 1 is 3. Ingress 2 is 2. And then plus is on the mill. And once it's executed, the result of 5 is on egress. No? So ito yon, no? Ingress axis, dalawa, no? Basically, it can compute two variables and store the result on the output called egress, no? Do you follow? So, there are two types of cards, no? The operation cards, which are transferred to the mill, store operations. Do you follow? No? There are three types of cards. These cards are the input devices. They are like the keyboards of the modern computer. Wala kasing keyboard no? Do you follow? So all the commands are stored in cards, in a Jacquard loom. Do you follow? No? Any questions? We still have 30 minutes. So the operation cards can store different operations like plus, minus, times, and modulo. Do you follow? Okay. Now, there can be also combinational cards. These are used to perform jumps and loops or repetitions. No? Special cards used to ring a bell when the program is holds to a succession, no? Halt the engine or give comments to the operator. Outputs. No? Number cards. These are the data cards. Okay, these are the cards which store the 40-digit decimal numbers. No, ito yun, no? Pwede siya negative numbers. Negative, both negative and positive numbers. Variable cards are used to transfer values from the store to the mill. Ito pala yun. Kasi you can transfer values from the store to the mill and the mill to the store. Do you follow? No? So they use variable cards. Nowadays we just call them memory variables. Right? When you write a program, you don't use cards, you use variable names X and Y. Okay? So variable cards are used to transfer values from the store to the mill or from mill to the store. The machine can erase the numbers as it transfers them, which means like, setting values to 0. Okay? Special variable cards. In case the store is full, the mill needs a special variable. No? Kung napuno na yung store, kailangan ng special variable. So these are examples. No? An operation cards require 4 holes. So ang isang operation cards requires 4 holes to represent either plus, minus, divide, or times. No? Mayroon pala siyang divide. Do you follow? So ang operation cards merong 4 na holes. So hole 1 indicates plus, hole 2 indicates minus. No? Depende kung saan yung hole. Number cards occupy 50 columns of possible punches. So ibig sabihin, each digit is stored in a column. So there are 50 possible holes to represent a number. Okay? And a variable card, 5 possible punches. Only column of 5 possible punches, no? Representing a number which is read from the store. These are the 5 possible punches, no? A number read from the store. Read from the store and erased in the process. Read from the mill and put into the store, no? That's the third. And read from the card reader or the punch card reader and transferred to the mill. Okay? 3 more columns of possible punches would be needed. We'll have an example program, no? Okay? Here's a simple computation, no? Okay? N means operation, no? I'm sorry. Sandali. Ito yung mga commands niya, no? Okay. For example, you have N001. N is a number card, which means N represents a number card, no? This is an example of a card, no? The following number specifies the address in the store where the memory should be loaded, much like an array index. So when you say N001, okay, 500. 500 is put into address 001 in the store. Do you follow? No? N is a number card. Okay. L is an operation. Should be loaded, no? So ilo-load yung number from memory to the mill, no? From the store to the mill. I'm sorry, no? Puts 500 into memory address 1 in the store, no? Baligtad pala, no? It puts 500 to the, no? So and this is a simple program, no? This computes 500 divided by 30. Ito lang yung gagawin niya, compute 500 divided by 30. Okay. The first command is N001 plus 500. We put 500 into address 001. And then N002, 30. This is a number card. Puts 30 in address 002 in the store. L001 loads the number 001 and stores it into ingress 1, which is the variable in the mill. Okay? And load 002 loads the number in 002, which is 30, to ingress access 2. So, ilalagay niya sa mill. Okay? And then P prints the current value of the egress access. This outputs, no? Divide, no? There's a number card. This is an operation card before the load. So, nauna yung operation kaysa data. Do you follow? First, it signifies a divide. Then, it loads the dividend. And then, it loads the quotient. And P means put the result in the egress axis. Okay? And S003 will store the result of 500 over 30 to S004. And B means ring a bell to tell the operator that it's finished and look at the egress axis. Okay? You follow? Now we'll have a sample program other than that. No, this program only computes 500 over 30. Okay. Here's an example of a factorial program in the analytical engine. You can download this from our site. Fourth factorial. Who knows what a factorial is? Factorial. What is the first factorial? What is the first factorial? Anyone? 1. That's good. No? Why is 1? Why is it 1? Because it is 1 times 1. What is the second factorial? 2. Because it's 2 times 1. The third factorial is 6 because it's 3 times 2 times 1. The fourth factorial is 24 because it's 4 times 3 times 2. So the factorial, the nth factorial is the number of multiplications from 1 to n. Do you follow? Do you follow? Okay. Any questions?
And so far, yes, sir.
Okay. So anyway, thank you. What we are showing is a program that computes the fourth factorial. Can you view? Can you see my worksheet? Malakihan ko lang ha. Is it visible enough?
Yes,
Yes, sir.
Yes, sir.
This is the analytical engine ni Charles Babbage. Ito yung mill. The mill has ingress variable 1, ingress axis 1, and ingress axis 2. It has egress axis 1, no? Which is the output. Ito yung store. ST000 is the address of the first variable. 001. Kung baga sa memory ito, this is 0, memory address 0, 1, 2, 3, 4, 5. Do you follow? Okay. In fact, the fourth factorial, the nth factorial, was one of the programs demonstrated by Ada Lovelace, no? Si Ada Lovelace nag-demonstrate that the fourth factorial can be computed, or the nth factorial can be computed using Babbage engine. Okay? Pwede ka palang gumawa ng program to compute the nth factorial. This time, we'll just compute the fourth factorial. When we say N0004, we mean that the number 4 is loaded to the address 0. So which means the store will now have the value 4 in ST000. We call it ST000 to mean store 000. Do you follow? So this is a program now. No? Do you follow? Program na ito. N0011, which means the number 1 is placed on ST001. Do you follow? And then in N002, we place another value called 1. So itong tatlo, nalalagay na. No? This is the program in the Jacquard's loom. So imagine, this is the engine by Babbage. No? Meron tayong Jacquard's loom which contains the program or the input. We have the mill which is our CPU, and we have the store which is our memory. Can you follow? No? So ating program nandito sa Jacquard's loom. And then we say times. What is going to be multiplied? We are going to load 002 to ingress 1. What is 002? Itong 1. Do you follow? Itong 1 ilalagay natin dito. And then we have load 000. So 00 is 4, so it's loaded to egress access 2. Do you follow? Do you follow? And they are multiplied. 1 times 4. And the result is S002. So 1 times 4 equals 4. Ilalagay dito sa 2. Do you follow? Do you follow, everyone?
Yes, sir.
Yes, sir.
Okay. So did you get the program now? So ito yung pinakauna. 4 times 1 equals 4. Ilalagay dito. Okay. The next is minus. This is an operation card, no? From the cards loom. Minus. What will we minus? First we load 0, 0, 0, which is 4. So itong 4 ngayon dito, ilalagay dito sa ingress access 1. Ganito 'yon. The first command goes to the ingress access 1. The second command goes to the ingress access 2. Do you follow? No? Depending on the sequence. Okay? So L001 ilalagay sa itong 00 ilalagay sa ingress access 1. L001 which is 1, itong 1 ngayon ilalagay sa ingress access 2. And since we minus, do you follow? 4 minus 1 is 3. We store it to 0. Do you follow? We store it to 0. The value 3 is stored in 0. So it's like a loop which loops from n to 1 or 4 to 1. The first value is 4. The second value is 3. Do you follow? Everyone?
Yes po, sir.
So we're trying to demonstrate how a program runs, no, in Babbage computer. So tapos na tayo sa first instruction, 4 times 1. The next instruction is 3 times 4. Do you follow? So we do a times. First we load L002. What is L002? 4. So ilalagay siya sa ingress access 1. And we load L00, which is now 3. You follow? Previously it was 4. Now it's 3. So we now load it to egress 003. So, and then we multiply. 4 times 3 is 12. And we store it to egress 002. Now, by the way, to compute bakit i-store sa 00 ang 3? Because this is our next number to multiply. No? Ang next multiplier natin nasa 000. Do you follow? Dito yung next multiplier. The first multiplier is 4. The next multiplier is 3. Do you follow? So yung nandito sa 00, ito yung next multiplier. Do you follow? Now, to do a factorial, you can say 1 times 2 times 3 times 4, right? Or you can also say 4 times 3 times 2 times 1. So this is the reverse process. This is a fourth factorial which starts with 4. This is not a fourth factorial which starts with 1. Do you follow? Pero pareho, in the end, they will have the same result. Okay? So, Labrador, is it correct now? Our variable 00 will store the next multiplier. The first multiplier is 4, so we say 4 times 1, 4. Okay? The next multiplier is 3, so 4 times 3 is now 12. And then we minus 1. We minus 1 from the 3, so dito yun na naman yung next multiplier, which is 2. Do you follow? Okay?
Yes, sir.
So, ang next multiplier nandito. Okay? So, we do a minus L00, which is 3. And then L001. What is L001? 1 ito palagi. So, 1. So, we do a minus. We store it to 0, 0. So, now 0, 0 is now 2. Do you follow? 2 na siya. Because the next multiplier is 2. So, now we do a times. No? Ang una nating i-times is L002, which is 12, the partial product. Take note, 002 stores the partial product. 000 stores the next multiplier. The partial product is 12. We load 2. So 12 times 2 is 24. Do you follow? We repeat the same process until we reach 1. The final value is 24. You can do this yourself. You can download this worksheet, no, in our site. Do you follow? Pwede ninyo ito i-download and study this because I'm going to give you I'm going to give you a programming for the analytical engine. Hindi ko pa tumahid. Okay. Okay. Do you follow? Okay. Fourth factorial. I'm going to look at the no. I'm going to give you an assignment next meeting. So far, wala muna, no? Okay? You're going to write a sample program. No? You're going to write a sample program. Maybe a different computation, no? Wag na lang muna Celsius to Fahrenheit, no? And meters to feet. Maybe I'll give you another, no? Any questions so far? Okay? So that's about the very first computer, no? It's called the Analytical Engine by Charles Babbage. Okay? Any questions so far? Next meeting, I'm going to give you a programming assignment. No? For the moment, you're excused. No? Paano malaman kung sa ingress access 1? Now, there's a question by Kanakan, Ace Kanakan. Paano malaman kung sa ingress access 1 or sa ingress access 2 ilagay ang number? If it's after the command, no? After the command, do you follow? After the operation card, the first command goes to the axis 1. The second command goes to axis 2. Do you follow? No? Okay? Kanakan? Do you get my point? Okay, so kung unang command,
Sir,
papunta dyan. Kung pangalawang command, papunta doon, no? Do you follow?
sir,
And,
yung baba,
ha?
pwede mag-ask po, sir.
Yes.
Yung nasa baba sa number, sa 3 sa ingress axis 1,
Which
yung
line
number
number?
1 po, line number 20,
20. Okay.
20.
This one.
Dapat, di ba, sa ingress access 2 ang 1, yung baba sa number 3, baba sa 3.
Ito ba ito?
Hindi.
Oh,
Ay,
sorry.
hindi,
No.
yes
Sorry.
po.
Okay.
It should be here.
Yay!
Sorry. Thank you.
Kinabahan kami, sir.
Okay. Sorry, no? It should be here because this is the second. Thank you for that, no? Hindi ko na notice. I'm going to update, no? I'm going to update the, ano? I'm going to update the source in Dagler. Okay? Any more questions? Sir, sa 27 and 28, yeah, that not be, yeah, dapat ito rin. Sorry, no? Dapat dyan din. Okay? I'm going to update. Save as. Update ko lang sandali, no? Let me do that. Okay, let me just edit now in case I forget. Okay, so I've uploaded updated the file now. So when you download, it's already updated. Hindi ma-change ang number sa memory. Ma-change. Yes. Let me do that. Can we change the number in memory? Yes. Basta depende doon sa program, no? What I'm showing is the factorial of 4. But you can do a factorial of 5 or a factorial of 6. Okay? Pwede. In fact, if you look at the operation, no? there are loops. Wala pa tayo masyadong source. Wala tayo masyadong source, but kasi masyadong luma na itong machine. This is a very old, this is a very old machine. In fact, pwede siya mag-repeat, no? Kasi meron siyang jump. This is a sample program without a loop. Pero meron siyang sample with a loop. Do you follow? Ito, this is shorter. Do you follow? So, depende ang ilagay. Kung ilagay mo dito 4, this computes the 4th factorial. Ilagay mo dito 5, this computes the 5th factorial. Let's discuss this next meeting, no? Factorial ba ito? Let me look at that. Oh, yes. This is the 4th factorial without a loop. This is a 4th factorial with a loop. Do you follow? Okay. This transforms numbers into Boolean. Okay. So meron siyang command CB11, which means jump, no? Jump to 11 depending on the result if it's a negative number. Okay. When n is subtracted from 1 and results in 11. So in the case of 4th factorial, 1 minus 4 will set the lever to negative, no? Okay. So will be calculated 1, 1. So it will go to 1, 1. It will go back to the first. Okay. They follow? So in our source, no, the first version is a version without a loop. Ito, which we trace in our, no. The second version is, we will trace this next meeting, okay? Sir, kung mag-quiz, good, or mag-assignment, ano yung given sa assignment? The given in the assessment, okay. Isang question pa, no? Saan galing yung 411? Okay. 4 is there because we are going to compute. This is set to compute the 4th factorial. Do you follow? If this is 5, this will compute the 5th factorial. Do you follow? Itong 1, 1, these are the initial numbers. No? 1 is always the value that you subtract because you subtract 1. In each step, you subtract 1. Like 4 minus 1 becomes 3. 3 minus 1 becomes 2. 2 minus 1 becomes 1. Itong 1 na ito is fixed at 1. But this one is the partial product. Okay? The first one is the partial product. The first product in the factorial is 1, di ba? The first factorial product is 1. The next partial product is 4 because 4 times 1 equals 4. The next partial product is 12 because 4 times 3 equals 12. The next partial product is 24 because 12 times 2 equals 24. 24 times 1 equals 24. Do you follow? Okay. Yup. Saan galing yung 1, 1? The first one is the constant subtrahend. Because we will always subtract 1 from the next multiplier. Okay? Start, stop, step. Parang start, yes. The first command is the start. The last command is a halt. There should be a halt here. Let's look at that. So sa actual sample. Actual sample na sa source, no? Okay, H. By the way, there should be an H. Let's put a bell and an H. Lagyan natin ng B and H. Okay. Dapat merong bell and the halt. Okay. And then let me upload this. Mabagal ang ano, no? Regular. Just going to upload this. Mali. Okay. So any questions? Parang start, stop, step. Yes. Start is the first command. Stop is halt. Okay. Step. Step is CB. Okay. Any other questions? We're running out of time now. I'll upload the video. Okay. I'll upload the video in our Dagler site. Okay. So far, do you have lumapay? Do we have lumapay? Wala. Placer. Pungase. 3 people are absent, no?
Meron po kung ano.
Pungase, okay. Anyone else? Okay. So see you next meeting. Wednesday, same time. Okay. Thanks for coming, everyone.
Last
Okay.
question na po, sir.
What's up pa?
Habol.
You have 2 minutes.
Yung sa, ang first value na nasa ST002 po, ano po yun?
Asan ang first value? Which line?
H5. 5.
Ay, ito. Ito
Yes
ba?
po. Yes po.
Okay. Which means we are going to store the value 1 to 2 here.
So, okay lang po siya. Like, okay,
This is the first partial product is 1.
Okay.
But the first partial product is 1. That's why we are storing this. And when 001, this is our constant decrement. Diba?
Okay.
Minus natin, from 4 minus 1 becomes 3. 3 minus 1 becomes 2. This is our loop. Our loop counter yung 00. Ito yung loop counter natin. If you're familiar with the loop counter. Do you follow? Kung sa C++, minus I. Do you follow? Do you know C++? Minus 1. Okay? Minus 1 every time. 4 minus 1, 3. 3 minus 1, 2. Okay, so we are running out of time. I'll stop the saving and the recording. Okay? Upload the meeting. You can ask your questions. By the way, there's a site that we have in our class, no? We have a forum. You can ask your questions there. Okay, I'll check the forum tonight. Everyone, kung meron kayong mga pahabol, okay, you have a forum here. This is for 301 ba tayo? You can ask your questions here. Okay? Okay. So I'm sorry, no? We have to leave because it's already 3:03 and we're only up to 3 o'clock. Okay. Anyway, we'll meet again. Okay. Thank you very much for coming. Okay.
Thank you, sir. Bye.
Bye. See you, everyone.
Thank you,
Hi,
sir.
sir. Thank you, sir.
Thank
Thank
you,
you,